Hi, good morning. I'm Oliver Gao. I'm the director of Cornell's System Engineering program. I have been very fortunate to conduct what I call these system conversations with our invited speakers to our Cornell Ezra System Seminar Series. Today, actually, I'm very happy because we have one of our own. Actually, we have Richa Sirohi, and actually, she is end-to-end information systems engineer at NASA's JPL Propulsion Laboratory. She works on the communication architecture for the Psyche mission. Richa has previously worked on the Mars Perseverance rover, the Cold Atom Laboratory multi-angle image for aerosols, a lunar mission concept, and also Europa Clipper. She also founded, and this is, I'm really proud of that. She also founded JPL's early career community for young professionals. How beautiful it is because, young professionals are really, the future, right, of all our missions. Richa was the 2021 recipient of the NASA JPL Bruce Murray Award for her work in educational outreach. So, Richa, welcoming back.
Thank you.
I'm so glad to see you back. So, as I was, looking at both the abstract of your talk as well as, the wonderful things you have done, I was going to ask you to share your experience and how your career, how your life developed and brought you to this point. Of course, it will continue, but I think it is kind of, we want to know the path of your trajectory and also where it's heading in the future.
No, that's a great question. I actually grew up in Omaha, Nebraska, and so it's a place that was quaint and peaceful, but it wasn't a place where I had exposure to a lot of these, great academic pursuits. I didn't know what was out there. I didn't know I could go work for NASA or even all the areas of engineering. I simply enjoyed my physics class, and I realized looking at colleges that if I started in engineering, I could switch to something else. But if I, started somewhere else, I could never switch back to engineering and finish in time. So that's why I dived into engineering, and I thought, let's see where this takes me.
So having an engineering degree is like having an option in hand.
Yes, it's a good foundation, right?
Yes.
It plays to all the STEM skills, and it really opened a lot of doors and windows for me. I went to undergrad at Baylor, and I studied mechanical engineering. I liked being tactical. I liked having my hands on when building projects. But then over the course of my studies, I realized A, I had an interest in material science, and B, I was actually really good at the strategic thinking, at leading teams, at understanding the interfaces in the design. And I didn't quite need to be the one building it. I just really liked having a high level view of how the system worked. I found this out through various internships I did. I actually first interned at JP Morgan. I did, data side and the tech side.
That seems to be quite different.
Very different, right? But it was a great way to gain exposure in industry and understand how workplace works, and really taught me that my engineering skill set is applicable in many different disciplines. And so that opened a lot of doors for me because I realized, I could go in many different directions. I'm not constrained to mechanical engineering. After that, I had an interest in aerospace. So I interned at Northrop Grumman. It's a well-known defense contractor. And while I really loved the work, I realized I was really far from the science. I'm very passionate about working with scientists, about educational outreach. And I thought, okay, how can I bring all of these passions together? So I had an interest in doing some research, and I found my way into an internship at the NASA Jet Propulsion Lab. And that's where I find myself today. That internship was very foundational for me. I worked on the Mars Perseverance rover, which was in development at the time. I gained exposure to so many different disciplines that go into building something like that, such a complicated system with such a complicated use case. And it was extremely inspiring, right? I could go and I could share this knowledge with the world. It would inspire others to, as we say, dare mighty things at JPL, and not just in the field of engineering, but in any field that students pursue. And so I found this calling, if you will. And at the time, I was also planning to get a graduate degree. And so I had this great advantage, I think, when I came to Cornell for systems engineering, in that I knew I was going to go back to JPL for a full-time role. And so I was able to really craft my education here, right? Like I took coursework in aerospace, and I did research in sort of soft robotics, which really played to my material science background. And because of that, I really loved the systems program, right? There was so much support from the faculty, and I got so much ownership to craft my education. And I didn't quite see that in other programs, when I was shopping around for where to go to grad school. So that was a big calling for me. And it also helped me build that skill set, right? Because I wasn't having to pick one singular discipline to focus on my time and energy and career path in. Instead, I was building this breadth of knowledge and really preparing myself for solving any sort of complicated problem that I run into. So now what I do at work is very different from anything I studied, but because I think of that core systems education, I'm able to pivot in the directions that are needed on my various projects, right? And it's incredibly important to be needed, I think, whenever you're coming to solve a problem and to fill those holes. And so what I do nowadays is what I call end-to-end information systems. It has many different names depending on what aerospace company you're talking about, but at JPL it means everything from when data is produced all the way through when it is archived and given to scientists. So that's what I'm going to talk about in my talk. Very different from all the material and mechanical sciences that I studied. But yeah, I'm very passionate about my work.
Beautiful. Thank you so much, Richa. Yeah. Because I think when you were talking, and I took down some notes, and I wrote down 3 words: interns, inspiring, and calling. It seemed, and I think I really admire how your career developed, because it seemed like your career and my career, I can see the huge difference. My career was so kind of boring. It's what I'm, in a sense.
Yeah.
It's that I did my undergraduate study, I went to graduate school, and I became a professor. So kind of, because my life so far has always been on campus. But for you, and I really admire that, because you can see that you say that you did an intern and you found out something. And from that thing you found out, you kind of adjust your direction and you proceed, and after a while you did another intern, you found out something else, you adjust that. This is really like, it's kind of I think the best way of learning and growing. And the good thing is that your growth was based on what you learn from the real world, what the real world. So in that sense, and you mentioned this, this calling, and you're absolutely right, because I think for all of us, or everyone, we want to do something. Of course, we want to do something to develop our career, but we do want to have an impact. We want to contribute and to the society. So in this sense, and what do you see as the major challenges, facing us, facing humanity and our society? And of course, I believe among all of those challenges, kind of like space related, it will be one, and that's why you choose that. So what do you see as a major challenge? Then why did you choose? Because you went through all these things, from JP Morgan, and then now that the JPL, the system. So why do you decide to respond to the space calling?
Yeah, no, that's a great question. First, I just want to clarify, it's Richa.
Oh, Richa, sorry.
No problem.
Okay, yes. Okay.
No, but that's a great question. The aerospace field is booming right now. There's so many more missions. There's startups coming into the field. Technology is advancing rapidly. It's a huge problem as to how we integrate all of those things. How do we size the best mission based on all these external private resources? So that's a problem that is engaging. There's more and more science to be done. There are more science pipelines to be given. All of that is very exciting about the aerospace field in general. What I really see as a huge problem coming up is obviously climate change, right? That plagues the minds of many young people. What NASA does is, we're not at the forefront or at the front line of fighting for changes in policy, but we are the ones who provide vast quantities of earth science data. And that is important work too, right?
Yes.
Yeah, it sometimes takes many years for that data to then turn into impactful policy to prevent harm. But I like being at that source, right? If I don't do the job, the very foundation of it, right? At least it's all about providing that knowledge to the public, providing it to universities, seeing what students and researchers can really do with that, and how passionate the people are, right? they're not going to be passionate about solving a problem if they don't understand the problem. So I like being that person who goes and investigates. So things I'm really passionate about working on next after my current mission launches are earth science orbiters, right? I would love to learn, as a technical area I'm not familiar with, is how we communicate with ground stations on Earth. I'm used to deep space missions, so that'll be an area of learning for me. And it'll be really exciting to be part of something that's contributing so much to humanity. To make positive change, right? We can study changes in the polar ice caps. We can study the way, surface water is changing overall, which will impact shipping. It'll impact where we place wind turbine farms over the ocean. We can study landmass changes, which impact agriculture. And we can be helping nations around the world, right? When you look from space, you aren't looking at one nation, at one nation's interest, right? Science is for everyone. And I'm really proud of the way NASA distributes its data. And so that's another reason, right? I'm so passionate about the institution I work for and hoping to work on missions like that in the future. That'll be huge.
That's really exciting. Thank you, Richa, because you can see that you emphasize, you would like to work on something that is fundamental, right? And that's absolutely right. And also, a lot of NASA, exploration and endeavors, it's really, you can see that I don't think it's just for one country. It's really for for the global, I think, benefit, right? So it's like a kind of what I call miraculous systems eyes.
Yes.
Right, and you can see all these things so that we can make holistic decisions. Right, I think that's beautiful. So of course, down to the day-to-day work, right? While we want to be guided by all this exciting vision, but on the day-to-day work, and that's really what your training comes into play. And you are an end-to-end information system engineer.
Yeah.
Tell us about this end-to-end information system.
Yeah,
because I don't think many people know about that.
Yeah, it's an exciting role. Whenever you're developing a very complex systems, there's different layers to it. At the very bottom layer, it's very foundational, right? You have all the cabling that's made, each of the wires that's made. This is the metal that's going to be used. And then a level up, you actually see some of those subsystems come together and be tested. A level higher, you start to see some of them be connected to each other and tested. And at the level at which I work, I'm pulling together the entire spacecraft and connecting it to the ground station and connecting to all the operators and the users. So the viewpoint is literally from when a scientist says, this is the data I want to receive from this mission, and this is what we're going to do with it, all the way through when they actually receive the data is everything within the end-to-end information system. What's unique about it is I don't own any of the hardware in that system. It's owned by all these other system engineers and different teams that deliver different pieces. They might deliver an instrument, they might deliver a portion of the ground system that will then process the data. I don't own any of those pieces, but I have to make sure that they talk to each other accurately, that we get the quality of data we're expecting, that we get the quantity of it, that our data is secure, that we're able to retransmit for our data, right? So all of these various functions and their sort of criteria that they have to meet are within my purview. And so it's a unique problem because, I don't have a lot of ownership over changes, but I have a lot of responsibility. And so what I love about my job is it's actually very people-oriented, right? I have to pull people together and ensure that their shared understanding is accurate, right? So that the requirements we write at different interfaces are with the same common language. I have to ensure that when I test the system, I'm testing it in a very flight-like way. When we say that, it means in the ways that users will actually use it. We want to ensure that it's going to operate the way they expect when we're actually out there in space exploring. And so that requires, so many different legs and pieces. And so I love where I sit because I get a full view of the mission. I know how it's going to be flown. I know how data is generated and stored. I know how we command the spacecraft. I think if you work at a lower level, you only see one piece of the story. And there, people are called to different types of work. Some people like the nitty gritty and they really want to focus on one area. But I like EIS, End-to-End Information System, because I get that high level bird's eye view, if you will. And it is a lot of responsibility, but I think that's the way you grow. So
wonderful. So I think Richa, you talk about, as you mentioned, you don't own any specific technologies, and you have to work with people, and also these people are across so many different disciplines. And the field. So I think in your case, and actually your daily work is really a beautiful exemplification of systems engineering, right? Because as we talked earlier, we mentioned climate change, or we even mentioned, kind of more specifically, to the space explorations, right? All these tasks and these challenges, they are systems in nature. However, even if you look at Cornell, or MIT, or Berkeley, Stanford, our education system, there are still mechanical aerospace engineering, civil engineering, chemistry, because our education are still in this traditional siloed, this format. While as a result, because we produce a lot of outstanding engineers or scientists, they do their own work with excellence. However, now in your daily work, you can see that you have to put all these people working together. And I feel that, people like you is really a rare a resource. And you have to be able to, so actually I was wondering, how do you talk to those people from all those different disciplines? Somehow, I guess, because even you and I, when we communicate, at the least, for example, we're speaking English. So imagine that if I'm talking Chinese to you, so how do you find the common language? You can speak to all those people.
Yeah, that's a great point. When I was a student here in the systems engineering program, I took a class in model-based system engineering. And what I liked about that course is you learn all these different mechanisms of modeling a system. All of that was great. But like you said, our education system is a little bit rigid. We teach you one problem, and we ask you to find the one solution based on the information you're given. But in the workplace, there's a problem filled with multiple problems, and you're not going to have all the answers or the pieces of data, and you still have to go solve it as best you can, right? You have to ascertain when the problem is solved enough for you to reach a point of success. And so, one thing I find that's interesting, sorry, I lost my train of thought.
It
happens, yeah. So what I find is really useful is actually using those skills of modeling and those different types of pictorials to then work with teams to fill in the gaps, right? If I draw what I think the system looks like based on what limited information I have, and I show it to these teams, it's much easier for them to communicate where they're seeing deviations. And it's also much easier for me to realize what words they're using for different functionalities or different systems, and I become sort of a translator. And that model becomes the translator between different teams, and it becomes a sort of working document and a working design. Even though the system already exists, the model itself is growing to fill in all the color, if you will. And so that's what's been really helpful for me. We have incredible user-based study, human-centered design researchers who assist us on the day-to-day. They give us new modeling tools. They're in the room. And as non-engineers and non-scientists, they really help us break down the language so that we're talking sort of in normal human terms. And then we build back up in complexity. And so it's quite a process.
That's wonderful. So essentially, you are a conductor.
Yeah.
Right, you have all these musicians, right, playing different instruments.
Yeah.
I think that, of course, we know the importance of conductors, right? So in that sense, of course, I really appreciate it's because you mentioned earlier. I really appreciate this attitude you have. Because of the training you got before, it's not necessarily, right, some specific knowledge that you have turned, but it's really the capability of obtaining new knowledge in a given short time and adapt yourself to a new project or new problem. So in that case, I can imagine, while you're a system engineer, you're model-based system engineer, you have all this equipment knowledge to speak to all these different people, but I assume that maybe from time to time you probably come across challenges or difficulties. So how do you deal with those?
Yeah, that's a great question. Are you asking about technical difficulties or more people-oriented difficulties?
Any you'd like to share with us?
Yeah, no. So when it comes to technical difficulties, sometimes it's because there's a knowledge gap, right? In my case, I'm a fairly young engineer, and I'm hungry for knowledge and to solve problems, but it helps to be cognizant of the areas in which I don't have a lot of knowledge. Say, we have a bunch of clocks on the spacecraft, and we have to ensure all the clocks line up and sync. and relativity begins to play impact, and we don't want the clocks drift because we need to make sure we know where we are in space and when our data is being created. Now, this is an area of my job that I'm not as familiar with. I haven't had a lot of responsibilities here, so when I'm often tasked in that area, I punt it upwards, right? I ask more senior engineers, even if they're not on my project. I ask my managers. I make it known that this is not a thing I don't know. It doesn't help anyone to sort of step back and try to pretend like you've got it, or try to make it through with confidence, especially if there's a technical problem. So that's the biggest advice that I would offer there, and the biggest thing that's benefited me in my career is just to be open and honest and have that integrity, right, about your knowledge area. And often you'll learn and grow through it. When it comes to people problems, it often helps to have a calm, set-aside discussion. We have a great training at work called Crucial Conversations. And when I was going through the class, I thought, oh, well, this is kind of silly. They're telling us about how to be kind to each other and set up, meetings in which we talk about, what's bothering us. But then when you enter the workplace, and you maybe don't realize this as a student, but, people problems and people clashing because they're really passionate about their solution or their conception of how things should be happens all the time. And good system engineers and good people leaders are the ones who can set aside a separate time to have those discussions, curate the conversation in the room, and be a mediator for those challenges so that we can find compromise and understand where misunderstandings occur. I think the problem occurs when there's people clashes and the situation escalates because you sort of incite one group or the other, right? Or you show that you take sides. So where I live at the high level, right, I can't take any one side because my function exists between two systems.
Yes.
And I need both of them to exist in balance. And so that is both on a technical sense, I need to call in help when I can't answer the questions, and in a people sense, right? Like I need to make sure that both are enthusiastic about solutions and both are on the same page. So it's a process.
Beautiful. So essentially, you are really a system architect.
Yeah.
Right. It's architect is kind of all these different stakeholders, right? They have different technical capabilities as well as the aspirations and how. So this is actually very as a system architect. So actually, you are really helping the top level leadership in terms of decision making, right? So now we realize that actually engineering computation, calculating the numbers now probably is much easier than, for example, making compromising decisions, right? It's a trade-off.
Yeah.
Because I feel it's kind of because when you're dealing with this kind of all these different, even all these different stakeholders, each one they have very kind or nice aspirations, but they're not necessarily going to be lined up, exactly, right? So it's about, I think, somehow. So what's your decision criteria? When you have all these, not necessarily conflicting, but not very well aligned objectives of all these different teams, but you have to, as we think, you have to orchestrate them together, for a beautiful delivery of the mission.
Yeah, I think this goes back to our conversation about how in school you're sort of given this one problem and there's one solution. But in engineering, there is never one solution. When we design a spacecraft, it could come out so many different ways from its initial conception, right? And so when we approach our design and our sort of engineering challenges, you really have to ask yourself, okay, well, what is driving these design decisions? Are we basing this off heritage that, JPL is really requiring us to use because we can't afford another system, or because this is the system that provides the least risk, right? It's always, we got that triangle in engineering. It's risk, it's time, it's money. What are the factors driving our design in this situation? And then you really have to understand, what is our baseline for success? How do we make the system operable enough so that when we're in flight, when we're orbiting this asteroid, we're able to get the data back that we need? Okay, well, what are the challenges? Are there workarounds? You go talk to the actual users. Is this something we can live with? You go talk to the engineers. You say, is there a way to enhance this? You go to the managers. You say, okay, if we enhance this, what is the cost? What is the risk? Can we eat that risk? Can we pay for this? And it's this constant iterative process. And even while we're testing, we're finding issues and we're asking those same questions. Systems engineering isn't about designing a system and then implementing and developing it. We have those defined phases, but we really are always going back and saying, okay, do we need to change something? Does this trickle out, or is this a quick fix? So later and later it gets, the closer and closer to launch, the fewer changes you can make, the more accommodating you have to become, right? So it's important to have a robust design earlier on, but it's also important to be able to pivot in those later phases. We have a vast number of criteria that aren't just based on sort of risk or money, but like I was saying, we have users, we have scientists who are expecting a certain fidelity of data, a certain quantity of data in order to achieve the science and the science objectives they're looking for. But we also have the operators, the people who use our system on the day-to-day. And so between those two users, we have to make sure that both are happy. We often have this fight between the engineers and the scientists because we want all this engineering data that makes sure that the spacecraft is healthy. It'll tell the operators what's going on with the spacecraft. And we have the scientists who are like, okay, you don't need all that data. Bring more science. Bring more of the instrument data. And so it's this constant tug and war. But that's where we make compromises, and that's where we have to say, okay, we have to make sure the spacecraft is healthy before we can get your data. But there's also no point to this mission if we don't get back the science. And so we're always going back and forth on that conversation.
Thank you for sharing that.
Yeah.
I think that makes perfect sense, Richa. So now I like to kind of because I know that later on you're going to talk about this mission to a metal world, and this is for many in engineering, and I think for all of us actually we're very curious. So tell us more about this metal world. You call it this asteroid 16 Psyche. This Psyche mission. Please tell us more because that seems to be very fascinating.
Yeah, no, it's a very cool mission. The mission is called Psyche, but the destination is also called Psyche.
Okay.
So it's actually an asteroid between Mars and Jupiter. It is one of the larger asteroids there. It was discovered, hundreds of years ago, but we haven't been able to get particularly close. If you see, I'll show the best picture we have of it, and it's just a smidge of pixels. But from our data that we've retrieved, even from a distance, we can tell that it's probably 30 to 60% metal. And it's very unique in that way compared to other asteroids. And we think that it was we're not entirely sure how it formed, but that's what we're going to go find out. We think it could have been a planetesimal, so it was a planet that was forming, and then for whatever reason it stopped. It could have been a planet that got bombarded by asteroids, and now it got stripped away, and now we're left with the core. In either of those instances, we think it'll resemble what the core of Earth looks like. We can go and study it. We can try to understand, okay, we can't look at the center of Earth, but we can kind of look at Psyche and think, about how planets are formed in our solar system. What was really happening at the founding of our solar system? How are planets formed overall? And so it's a very fascinating mission in that regard. It's what we call a discovery class mission. So it's not our flagship. It's not one of the Mars rovers. It's not these multi-billion-dollar missions. But it's also not that small either, right? Some of our Earth science orbiters are, a couple $100 million, which I realize sounds like a lot, but in the world of spacecraft engineering, it's not. So this comes in at sort of a mid-range, which is a good point because it's a large enough team where there's resources and we're doing a lot of big science. We're going to outside of Earth. But, it's small enough in that I as an engineer enjoy it because I get to learn a whole lot, and I get to understand the full system and all the science that's occurring. It's very targeted. We're gonna focus on one area and gain all the science we can from that. That's kind of an overview of the Psyche mission and Psyche asteroid.
I see. It seemed like you're saying that it's going to be this one. It's going to be the cruise will be there for about next 3 to 5 years.
Yes, about 3.5 years to get there. So
yes, 3.5 years.
Yep.
Okay.
So if Earth is about 1 astronomical unit from the sun. Psyche is anywhere between it's about 3 astronomical units from the sun. So it's twice the distance from the sun than Earth is. And so it'll be interesting because we leave Earth. With Psyche, we'll leave Earth, and it'll kind of slingshot around Mars. We do a Mars flyby, and then it'll catch up to Psyche, and it'll start to orbit Psyche. So when we reach Psyche, it'll be 3.5 years from whenever we launch, which is going to be August of this year. And then when we reach Psyche, we have 21 months of orbiting it, and we'll slowly get closer and closer and take more and more measurements. So that's our game plan.
Wow. So it's maybe I would just think out loudly. It's a metal world. So maybe probably at the core of the Earth, it might we know that there's much more content of metal, right? That might be right. There might be some similarities.
Yeah, exactly. Yeah, so we want to try to understand those. Perhaps unlock secrets to how Earth was formed.
Yeah. Now, how beautiful! It's really, as you said, this is really a discovery mission, right? And to fulfill our curiosity.
Yes. Yes.
Yeah, wonderful. So I think, Richa, you as I was reading your your bio, right? You've been doing wonderful things, and one of the things, and I really admire is this space people, right? You host this. So tell us more about that, and why did you do that? And so far, how is it going? And how are you enjoying it?
Yeah, no, that's a great question. So, like I said, as a student growing up in Nebraska, I didn't have all these role models. I didn't know about NASA. I'm a young woman. I'm a young woman of color. My parents are immigrants, right? There are all these other challenges that come with that identity. And exposure, I think, is crucial, right? Exposing young children, young minds to the possibilities of what is out there expands their opportunities. Not because you opened doors for them, but because you showed them where the door was and where to go find it. And so I'm really passionate about going back to schools, telling kids, about what's out there, what you can major in, what you could potentially study, right? It's not about getting more and more students to do STEM or space necessarily, but just broadening their horizons, and hopefully sparking an interest, right?
Give them exposure.
Yes, exactly. Yeah. And so I love doing that. And I love that simultaneous to that, I'm a woman and I'm a woman of color, and so I can go and I can help define what an engineer looks like, right? If I go to their school at a young age and I show up and I talk, their notion of what an engineer or someone in STEM looks like is now me.
That could be life-changing.
It is. It could be very life-changing. And it's a big responsibility, and I'm very passionate about it. And that's why I do so much outreach. And, the podcast was just an extension of that. In the pandemic, I was doing a lot of virtual outreach, which was great. I could talk to schools around the country from the comfort of my home in Southern California. But it wasn't the same as getting to interact with them live, and I felt like there was a limit to some of the stories I was able to tell. I was only really showcasing my identity as an engineer, and I realized there's so many other people who bring so much diversity of thought and experience to the field, and I wanted to highlight and celebrate that. So the podcast is all about interviewing just some of my friends in the industry, usually younger people who haven't reached the peak of their success. Sometimes when you talk to people who have, managed these large missions, you wonder, okay, well, I could never replicate their career path. I don't think I could reach it that far. But I love talking to people who are in graduate school and are also achieving success and what their path looks like. People who are starting out their careers, or people who are just taking on their first leadership role, and really showing that, look, these career paths are very tangible. You can achieve them too. Here's the challenges people had. And the conversation is really a lot like the conversation we're having is, what was your background like? What are the challenges you faced? What advice do you have for students? So I'm really passionate about just it's a way to document those conversations, right? So for people to find them and grow from them.
That's wonderful. It's really, as you say, it's kind of, it's really sharing, their experience, and also, give those, say, for example, high school students or middle school students, they say, oh, these people, they're very real. And they're not too far away from me. Because, maybe, when they share their struggles, that will echo in me as a viewer. And I say, oh, maybe, I experienced that, and seeing how she did that, now I get some tips, right? I think that's wonderful. So of course, I think Richa, as we get in, I do want to make sure you have enough time to prepare for a talk. We are getting to the end of our conversation. That you are one of our very proud alums, right? So of course thanks to people all our alums, right? Our program has been developing quite well, with interest as well as it's kind of the impact to the society, growing. So, what would you like to say to our cis engineering students?
Yeah.
Yes.
The biggest thing I want to leave them with is continue to strive for education. Right, your journey in education does not end at the end of a course. It does not end at the end of a degree. And I think that mindset, really opens you up to new possibilities and new areas of growth. Sometimes people come to graduate school, they're going to learn X, Y, Z quickly, they're going to go into the workforce, and they're going to dive deep into that one career path and area. And what I want students to understand is you should come here and you should try to absorb as much as you can, right? This is a dedicated time to learn. You can walk into a class, it's a very controlled environment, audit classes. I audited classes on exoplanets because they were simply of interest, right? And that opens up possibilities for me to work on an exoplanet, finding mission, right? All of these things, they come together. Do research. I picked a research-centric lab because I wanted experience in writing publications. I wanted experience in being in a lab environment, but also doing the systems coursework, right? Push yourself. That's really what I want students to take away from their whole experience in school, and then to not stop learning. I take seminar classes. I've taken classes in cybersecurity and data analytics and people management, and I've even begun in the past year a part-time graduate degree here at Cornell again in engineering management, just because I realized I missed that academic environment in the pandemic, especially. I was home quite a bit, and I thought, well, what a great way to use an hour or two of my evening to learn and to practice these skills. And the hope is that I want to have the knowledge before I end up in the role. I want to be a good engineering manager before I'm actually an engineering manager, so that I can come into those roles and really shine and really help the people that I'm working with in my team. And that's the same kind of mindset I really hope systems students carry forward.
Beautiful. I think, Richa, actually, I think this message that you just shared with us, is very consistent with what you said at the very beginning, your own career, right? I think that's why I was always, even I was telling my children, I say, some factors that make a person either, succeed or fail, those factors are very consistent. And I think, the message you just shared with us is basically, be very open-minded and be curious and keep learning. And I think that's really the thing. And for you, it's really, learning is not really, learning is not really the purpose. Learning is really a way of, I feel like, keep filling your bucket of life.
It's a way of exploring the world,
That's right.
Yeah.
Yes.
Yeah.
Yeah. And also, it keeps exciting you.
Yeah.
Instead of, this pandemic, what do? I become depressed.
Yeah.
Right. So I think that's it's really, I think it's a very upbeat attitude. I think that's the best I think advice.
Yeah.
So thank you so much, Richa. And I think we're getting to the end of our conversation. And I really appreciate you coming back. Of course, keep in mind, always feel free to come back. And as I was talking to all our staff and our students, I don't know if we were here, when we were in the orientation, I always tell everyone in system engineering, we want to build Cornell system engineering as a family, as a home, both intellectual home and also emotional home, for all of us, because I feel, this is system engineering. We don't have many people, right? Because of, this kind of system is still emerging. Right, kind of field, but I feel building a strong bond and also strong family will help us, kind of develop this new field.
Yeah.
Thank you so much.
Thank you so much. This is wonderful. Thanks
Great.
for having me. Yeah.
Yes. Okay.
Appreciate it. This is great. Yeah. Thank you.